Let's do some math. In this video, we're still going to talk about trigonometry. In this video, though, what we're going to talk about is solving for an angle measure given two sides. So we'll be given the ratio, but we're going to solve for the angle measure. Now to do this, we're going to start by just looking at a few of the equations. This is what it'll look like. Let me grab, let's see. Okay, so in part A here, this is kind of what it looks like already. If we have an equation, sine of x equals 4/5, how do we end up figuring out that 53.13 is what x is going to be? Well, if we have sine of x equals 4/5, what we need to do to get x by itself on that left side of the equation is to get rid of sine. We need the inverse of sine. We need the opposite of sine to get rid of it. So what is the opposite of sine, you might ask? Well, it's actually just called inverse sine. If we inverse sine that whole side, it gets rid of that sine value there, and we're left with just x. Now, anything you do to one side of an equation, hopefully you've learned by this point, you have to do to both sides of the equation. Why is that? You have to keep the values equal. So if you do it to one side, you have to do it to the other side. Now at this point, that right here, sine, that little sign of -1, that stands for inverse sine, that is a calculator question. So let me pull up my Desmos calculator here. And let's see, I guess there's probably a clear all button I could have done that with, but what we're going to do now is I'm going to type in sine, inverse sine, sine of -1. I'm going to go to the functions tab, and sine with the little -1 is right there. That's inverse sine of, go back to main. I can even use a fraction in my Desmos calculator and type in 4 down to 5. Okay, and I see that it's 53.13. You should take a second and make sure whatever calculator you're using that you can type in inverse sine of 4/5 and get 53.13. I'm going to try these other two problems real quick. Notice x is by itself other than a sine, or sorry, a cosine in this case, so I'm going to inverse cosine. Those will cancel. X is left by itself on the left side of the equation, but I still need to use an inverse cosine on the right-hand side of the equation. So go ahead and type that in your calculator, see what you get. I'll do the same on my side. Function, inverse cosine of, what was it, 3/4? Yep, 3/4. Okay, 3/4 is like 0.75. So I went ahead, oops, what did that say? 41.41. Okay, so again, make sure you can get that on your calculator, and if you can't, you might need to, one thing you might need to double check is make sure you're in degrees and not radians. Radians changes your answers, if you notice that, so make sure you're in degree mode on your calculator. Otherwise, you might have to just reach out and ask a question. Make sure you're using the -1, that's the inverse sine or cosines. Finally, let's do one more equation here. To get rid of a tangent, we need to use inverse tangent. So we have x equals, we've gotten rid of the tangent on the left side by using inverse tangent. But if I do it on the left side, I also need to do it on the right side. So I need inverse tangent of 6/25. Okay, it's like 0.24, I think. Let's see, inverse tangent of 6/25. 13.495. I'll just put 49. All right, pretty cool stuff. So if we have the equation, not too bad. We just use inverse. So the tricky part must be setting up the equation. So let's practice that. Here, let's solve for m. So starting from m, I have a hypotenuse. I have an adjacent. Am I going to need to label this adjacent down here? The answer is no. I'm not going to use an adjacent. I'm going to use the opposite over here, and I'm going to use the hypotenuse, but I'm not going to use the adjacent side because it doesn't have a variable or a number on it. Now I can set up an equation that uses opposite and hypotenuse. So SOHCAHTOA All right, so we have sine uses opposite and hypotenuse. Sine of my angle measure m, of my angle m, equals opposite over hypotenuse. And can I solve that thing? Well, yeah, I can solve that thing. What's the opposite of sine? Inverse sine. Okay, so I inverse sine both sides. And now I need to type in inverse sine of, let me bring up my calculator. Handy dandy Desmos scientific calculator here. I've got function inverse sine. Make sure I got the -1 up there. I don't want regular sine. I want inverse sine of 2/5. And that gives me 23.58 when I round. 20. I'm going to write it in here. 23.58. Now, it technically says solve for all the missing angle measures. Do I need to set up another equation starting from k? Do I need to start at angle k, relabel everything, set up another equation, and solve? Well, the answer is no. Instead, I know that all three angles in a triangle should add up to 180. So I'll subtract 90. I'll subtract 23.58 more. And I'll end up with, well, let's see, 180 minus 90 minus 23.58 more gives me 66.42. All right, cool. So I got 66.42 in there. And I've got the three angles in my triangle. I'm going to pause for a second. This might be a good time for you to try to set up the equation in the second one. I'm going to do it, but it might be a good time for you to pause the video and try it yourself. My first step is to label. I actually don't need to label the hypotenuse here because I'm going to need adjacent and opposite as my two sides. That's tangent of my angle. Now, I've had students in the past ask me, Mr. Fife, do you need to put that X? And the answer is no. I'm sorry, do you need to put the parentheses around the X? And the answer is no. Sometimes I do that just to make it clear that I'm doing tangent. I'm performing the trig function tangent to that variable. But you don't need to. Let's see, and so I'm going to inverse tangent both sides. And when I inverse tangent 17 over 11, I get inverse tangent of 17 over 11. I get 57.09. 57.09. Okay, so 57, and I'm just going to round it to 57. It doesn't tell me where to round to, so I'll round it to the nearest whole value. So I've got 90, 57. That means this one must be 33 because those three numbers will add up to 180. All right, in my third example over here, it doesn't technically tell me which one to solve for. I just have to solve for both. And so what I'll do is I'll start at angle N. Why not? I've got opposite to angle N, and I've got a hypotenuse here. So that's cosine of angle N equals opposite over hypotenuse. And when I take the inverse cosine of both sides, it gets the variable n by itself on the left side of the equation, but then I need to perform an inverse cosine on 4/14. And when I do that, function inverse cosine of 4/14, I get 73.39 or 73.4. And then again, I can subtract from 180. And by doing that, I get 16.6, I think. Ooh, I don't know. I would have to use a calculator to double check. If you're somebody who really likes steps, your first step should always be to set up an equation. Well, your first step should be to label. Pick the angle you're going to solve, label from there. Your second step should be to set up the equation. Your ratio on the right side should be done. It should be complete. There shouldn't be a variable in there. There should be two numbers. And what will happen is your angle will need solved for. You'll have a variable as the angle. Your third step then is to use the inverse of either sine, cosine, or tangent to get the variable by itself, and make sure you use the inverse on the other side as well and calculate that value. If you have more questions, please reach out. Good luck.